The next topic in Unit 1 was coordinate geometry. So we did a lot of different things. We used the slope formula, distance formula, midpoint formula. We talked about parallel and perpendicular lines. So this page really just consists of formulas and formulas that you have to know. They're not given to you, and what you can use them for. So I'm going to just kind of leave this up to you to read. And then we're going to go to the next page. We're going to actually do some examples. So we're going to kind of go through each of these. So for midpoint, there's a couple different types of problems. One for midpoint is finding the midpoint. So there, you can use the midpoint formula. So the midpoint formula on the previous page is you add your x's, divide by 2, add the y's, divide by 2. So it's the average of the x's, average of the y's. So you add up the two numbers, divide by 2, add up the two numbers, divide by 2. So if I'm doing this algebraically, I'm going to add my two x values. So it's going to be 0 plus negative 2 over 2. Then I'm going to add the y values. So 2 plus 4 over 2. And you simplify this, then simplify this one. So 0 plus negative 2 is negative 2 over 2. 2 plus 4 is 6 over 2. Divide this, we get negative 1. Divide that, we get 3. So there's your answer. Notice that I never combined these. I keep them as a comma because this is an x value, this is a y value, and most importantly, I keep coordinates or parentheses on them because it is a coordinate. So if you were to do this on a graph, I would plot my points. So A, B is negative 2, 4, 1, 2, 3, 4. Let me move this A out of the way. I'm just going to erase it and start over with that. So here is A. So what I need to do is find the middle. So to find the middle, well, you can count up and over. So it was up 2 over 2. Well, divide each of those by 2 because you're trying to find the middle. So up 1 over 1, there's your midpoint. So your midpoint, negative 1 comma 3. Same answer, which you should as algebraically. Graphing, I think, is quicker, but the problem with graphing is if you have decimals or you have fractions that you're dealing with as coordinates, or if it's an odd number, then when you divide by 2, it's going to be a decimal. So you can run into some issues if you only know how to do it graphically, so make sure you know how to do both ways. The next problem, still talking about midpoint, but instead of finding the midpoint, we're trying to find the other endpoint given the midpoint. So let's look at this one on a graph first, and then we'll switch it over to algebraically. So this time, M is the midpoint of AB. So if I start with A, it's negative 2, 6. So 1, 2, 3, 4, 5, 6. Here's A. And M is the midpoint. So that's going to be 4, 4. So 1, 2, 3, 4. 1, 2, 3, 4. So here's M. And I want to find the other endpoint. So I know that the other endpoint has to be over here somewhere so that this distance is the same on both sides of M. So what I'm going to do is I'm going to count from A. So 1, 2, 3, 4, 5, 6. So I went over 6, down 2. I need to repeat that to keep M exactly in the middle. So I'm going over 6. So 1, 2, 3, 4, 5, 6. So it's going to be over here. Oops. And then down 2. So down 1, 2, which would be right here. So over 1, 2, 3, 4, 5, 6, down 1, 2. So that's not the best scenario on this graph, but that would be the coordinates. So this goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it would be 10, 2 are the coordinates of that, 10, comma 2. So that's on a graph. Algebraically, you would just basically start out the same way where you're going to figure out how do I go from A to M. So I have A is negative 2 comma 6. M is in between them. And B is going to be down here. So I have to figure out how did I go from A to M and then repeat that to get to B. So how did I go from negative 2 to 4? Well, I had to add 6. I went right 6 is the same thing as adding 6 to your x value. So add 6 again, you get 10. Then you figure out how did I go from 6 to 4. So if you change from 6 to 4, You're going minus 2, which on a graph that's down 2 if you're subtracting 2 from the y. Do it again, you get 2. So same answer, different way of getting it. Again, this is going to be more accurate when you come across decimals. Graphing might be easier, but only works if you have nice whole numbers. Next thing on this page is the distance or length of a segment. So if you're trying to find the distance or the length, you're going to use distance formula. So x2 minus x1 squared plus y2 minus y1 squared. You could also do distance on a graph. I don't have a graph here, so I'm not going to do that, but you could actually use Pythagorean theorem. Remember doing that where you take and you connect these points, you draw a right triangle so that this becomes the hypotenuse, then you use Pythagorean theorem. That's fine, but again, only works if you have nice numbers. So I have distance formula. I'm going to subtract my x's, so it's all under the square root. So it's going to be negative 2 minus 2. The order that you do this in doesn't matter as long as you're consistent. So I could start with negative 2 or I could start with 2, whatever you want. Just make sure you're consistent. So I started over here, so I'm going to start with negative 6 for the y minus negative 1. And simplify this. So I'm simplifying parentheses first, so I get negative 4 when I subtract those. Here, this is going to become plus, so it's going to be negative 6 plus 1, so it's going to be negative 5. I'm squaring negatives. Whenever you square negative, you're going to get positive. So I get 16. When I square negative 4, I get 25. At this stage, you should only have positive numbers. You should never have negatives once you've squared the numbers. Combine those, and you get 41. And if you could break this down, you would, if the directions said to. But you don't have to because 41, there's not a perfect square that would multiply to give us 41. So this computer has a mind of its own today. So leaving it as square root of 41. The next page, we have parallel lines. So when we're talking about parallel lines, the first thing you want to know is parallel lines have equal slopes. So the first question here says, what is the slope of a line that is parallel? So that means equal slope to this equation. So if you have that equation 2x plus 3y equals 6, you need to first figure out the slope of it, which means you need to get it in y equals mx plus b form. So I'm going to solve for y. So you get 3y equals, I'm going to put the x part first, so it's in y equals mx plus b form. So negative 2x plus 6, keeping the plus for the 6, divide by 3. So I get y equals negative 2/3 x, and then this is going to be 2. So your slope is your number in front of x. So remember, y equals mx plus b. This is your slope. This is your y-intercept. So my slope of this line is negative 2/3, which means my parallel slope, so the slope of the original is negative 2/3, so my parallel slope is going to be negative 2/3 as well. And that's it for this one. Now this symbol here, just in case you didn't remember, the symbol for parallel looks like that. It looks like a slanted 11 or two lines that never cross. So that's your answer for that one. Example 2 is a type of question that always comes up. So you're writing the equation of a line that is parallel to this given line, and it has to pass through this point. So the first thing you need to do is you need to figure out the slope of this original line so that you know what your new slope has to be. And then you have to figure out the y-intercept, because if you're trying to write the equation of a line, you got to know two things, your slope and your y-intercept. So step 1 is going to be, let's find the slope of our new line. So I look at this, it's 4x plus 3y equals 7. So let's get this into y equals form. So I'm subtracting the 4x. Divide both sides by 3, every single part. So I get y equals negative 4/3 x plus 7 over 3. I only care about the slope. You're never going to use this old y-intercept. That's really irrelevant, because if you use the same y-intercept and the same slope, you're going to have the exact same line. You want a parallel line that passes through that point. So here's my old slope. is negative 4/3, which means the parallel slope is going to be the same. So the slope of my new line is going to be negative 4/3. It has to pass through this point. So step 2 is going to be to find the y-intercept so that it passes through that point. So there's two ways to do this. Algebraically, you take y equals mx plus b, you plug this in for x and y and solve for b. So you would take, you plug in your slope, you plug in this. So I'm going to plug in 2 for y, negative 4/3 for m, negative 6 for x, and I'm solving for b. So this would be 2. This is going to become, so if you cancel these, this would become negative 2. So negative 4 times negative 2 is going to be negative 8, or positive 8. So 8 plus b, subtract 8 from both sides. So you get negative 6 for b. So that's one way to find the y-intercept. The other way is to use the graph. So if I started at my point here, negative 6 comma 2, so 1, 2, 3, 4, 5, 6, up 2. If I start at that point and I count my slope, so my parallel slope was negative 4/3, which is down 4, right 3. So 1, 2, 3, 4, 1, 2, 3. 1, 2, 3, 4, 1, 2, 3. And you can find your y-intercept that way. So here's my y-intercept. This is the point that I had to start at. I used the parallel slope and I got my y-intercept to be negative 6. So either way, graphing or algebraically, you can get the y-intercept. You can't always get the y-intercept on the graph. Again, if you get those fractions or it's crossing like in between two integer values, then you would have a fraction or a decimal. So knowing algebraically is going to be important. But once you have your y-intercept and once you have your slope, you take those two things and your third step is going to be to write your equation. So your equation is going to be y equals negative 4/3 x and then minus 6. And then that's your answer for this question. And then the last thing here that we're going to look at are perpendicular lines. So perpendicular lines have negative reciprocal slopes, so that means flip and negate. So remember the symbol for perpendicular is that upside down T. So if you see that, that means perpendicular. So the first example here is what is the slope of a line that's perpendicular to this equation? So taking that equation, got to get it in y equals form first. So subtracting 3x from both sides. So I get 5y. Again, I'm going to put that negative 3x first, so it's in y equals mx plus b form. Divide by 5. So we get y equals negative 3/5 x plus 4/5. Leaving these things as fractions is going to be helpful. Don't try to get decimals here. So here's my slope of my original is negative 3/5. So the slope of the perpendicular is going to be flip that. So we get 5/3 and negate it, meaning it's going to become positive. So that's my perpendicular slope. The next example is similar to what we saw on the previous page, where you're going to write the equation that's containing this point, and it has to be perpendicular to this given equation. So step 1 is going to be to find your slope. So your slope of y equals 3x plus 2, I don't have to get it in y equals mx plus b form because it's already there. The slope of this line is going to be negative 3, which you can think of it as negative 3/1. So the perpendicular slope is going to be flip and negate that. So negate it becomes positive, flip it, it becomes 1/3. So this is going to be important. My second step is to find the y-intercept. So to find the y-intercept, you're going to use y equals mx plus b. You're going to use the point. So this is your x, this is your y. And you're going to use the perpendicular slope, not the parallel slope, not the equal slope. You got to use perpendicular. So I'm going to plug in negative 1. M is 1/3. And x is 3. And I'm going to solve for b. So I get negative 1 equals, these 3's cancel because it's like 3 divided by 3. Subtract 1, so you get negative 2 equals b. So there's your y-intercept. So right now you have enough to be able to write your equation, but on the graph, just to review that, I can go to my point, so 3 down 1, so here's my point, and I can count my perpendicular slope, which is up 1 over 3. So up 1 over 1, 2, 3, and then if you go backwards, down 1 over 1, 2, 3, you get your y-intercept at negative 2. So either way, you get your perpendicular slope, you get your y-intercept, last step. So once I have this and this, I can write my equation. Always using the perpendicular slope, because it has to be perpendicular to the original equation. Passing through that point would have to have a y-intercept of negative 2. So that's my answer.